I start.
The webinar is now live.
Oh, exciting. We got a few people coming in. We'll give it a couple minutes here, as normally this is the lunch break. Hey, Bob, you're in the wrong session. You're in the attendees. You're supposed to be on the panelists. Hopefully Bob can hear me. Are you ready?
Yeah.
All right, looks like we're recording. We should be good to go. So good afternoon, everybody. Thank you so much for your time and attention. This afternoon, I am extremely excited as Alpine is its fifth pillar, the manufacturing pillar. And what better way to start the manufacturing pillar than to talk about plan for every part. Now, please note everybody that is on the webinar has been muted. We would like to utilize the chat icon at the bottom of the screen to submit questions. Yours truly will be watching that and being able to address any questions that pop up with our panelists. So with that being said, Steve, let's go to the next slide. Plan for every part. So this information discussed in this session represents the views of the individuals and does not constitute legal advice. You should consult with your organization's leadership and legal counsel. So now that we've got that out of the way, let's get to the next slide. For those that do not know me, my name is Michael Wowen. I'm managing principal with Alpine Supply Chain Solutions. Alpine Solutions is a boutique supply chain consulting company where we take data and decades of experience to help our customers get the most from their supply chain investments. That being said, let's meet our panelists today. So first up is Bob Hollman. So Bob is an innovative, results-driven operations and engineering management professional with a strong track record of delivering bottom line results. He has a long history in automotive because he's in Detroit Rock City, aerospace, oil and gas, and believe it or not, pet food and commercial feed combined with successful completion of multiple complex projects through his career. Doing his 30-plus year career, he's demonstrated skills leveraging business acumen across diverse cultures. Bob is significantly experienced in the transfer of operations to international low-cost manufacturing sites and a proven record of successfully meeting or exceeding design, quality, cost product output, customer service, and delivery objectives. He himself has done several plan for part projects. Second is Steve Silvis. Steve is a supply chain leader with 25 years experience developing integrated supply chain solutions and decision support systems. His role has included Vice President of Engineering for Genco Supply Chain, leading solution design and implementation for warehouse and transportation services, operation management, sales and operations planning, order fulfillment, distribution management, inventory planning, aka plan for every part, as well as plant layout and design and information systems design. Steve really focuses on the tools and related focus areas such as transportation management, network design and assembly, plan for every part optimization. These tools have been applied to manage transportation transactions, design network solutions for the Department of Defense, Unilever, Canadian Tire, Kohler, Harley-Davidson, Briggs & Stratton, Sargento Cheese, Slimplast, Pillant, and School Specialties, amongst others. So with that being said, let's jump in. Steve, go to the next slide for me. So today, our panelists are going to talk about plan for every part, but our manufacturing pillar also includes capacity planning, supplier sourcing and audits, inbound process, facility layout, finished goods planning, end-to-end relational modeling. So this is the part where we're using technology and tools to optimize the situation, and then obviously discrete event simulations. So with that being said, let's jump into it. We've got a nice talk track today. We're going to talk about what is a plan for every part. We're going to go through a simple example, and then building off that simple example, we're going to add some complexity. We're going to talk about how the data and decision modeling will take into account the plan for every part. Then we'll talk about some sample applications. And then as you do a plan for every part, we will also show you some other findings. That being said, let's go to the next slide. And Steve, why don't you kick us off here and talk a little bit about a plan for every part?
Hey, thank you. And thank you again, Michael. Thanks for all for joining us. It's really, it's quite exciting for me. I have a lot of fun doing this. And I even got a plug for this. It's, you know, the plan for every part, if you read this right here, it can be very general or very broad for that matter. It's the right quantity, moved and staged in the right manner, the right time, from and to the right locations, and serving the market demands with finished goods. And that can be pretty like mom and apple pie, but really it does span across the whole supply chain. And I got to stop there and share with you all for joining us today. We're going to talk about our manufacturing pillar today, but I want you to know the relationship and why this comes so prevalent within Alpine is we have our strategic planning pillar, our system pillar, our warehousing pillar, and our HR pillar. And so it's really spanning the plan across the supply chain. And I really think that's what has brought the excitement to Alpine and the exciting group that we have working across the supply chain. Today, the plan for every part. So you might want to first ask, this is really nice, but what's it do for me? And here's a host of things that come to mind in the different projects that I've been on and that people that surface. Certainly simple enough, your design. Your product design can even have the plan for every part will have an impact on your product design, duplicate products or substitute products within a product design. The sales forecasting, certainly critical as to how much you're going to be buying of these components. The component sourcing, origins and quantities, order quantities, packaging. How does it package before it comes to me and I'm going to take it and put it into assembly? The inbound flow, you know, what mode of transportation and how frequent and so forth. The component storage, and I'm going to talk a little bit about component storage today. That's going to be the sample I use. Then the flow to assembly. Once it's stored, once it's unpackaged and put into the plant, how does it flow into assembly and when, in what quantities? Then there's the sub-assemblies. How much component goes to sub-assembly? How much sub-assembly is in the base before it goes to the final assembly? Then certainly the finished goods storage, because that's what you're trying to serve your customer with, and that can vary on seasons. Some might want to be regionally placed, others might just want to be centralized. And certainly then there's always that customer service. How long do I hold a part? How long is a part available for my product? A lot of these things come up, and there's certainly more that I hope you would all think about that you wanted to ask and learn about.
Boy,
so
Steve, yeah, I was just going to say, it sounds easy, right? Plan for every part, and then you show me all these, you know, inputs and how it can impact it. So it's probably a little more complex than a simple phrase, plan for every part, right?
Well, thank you, and it probably is. But when you just embrace it so much, you have fun with it. It always seems easy, right? Let me see if I can give that that same feel to you all. What I have here is a supply chain. This is a part supply chain, kind of a general one, starting with the design in the upper left, and then the 5 pillars across, or 5 locations: suppliers, receiving, component staging and storage, assembly, and then finished goods staging. And across the top, I have the decisions that we make: location, lead times, minimum orders, when to unload and transfer, storage types, packaging. And I'm going left to right. scheduling process. What's Kanban? What's a discrete part? Where do we, and then storage. Where do we store it? Where is it in the network? These are things that we have to decide for our parts and of course our finished goods as well. Across the bottom is the movements. And what I'm going to do is take a very simple sample, and the movements being quantity and frequencies, timing and locations. I'm going to take a small sample now.
Hey, Steve, can you go back to that real quick? So obviously, right, we look at this and we think about the parts in your supply chain, and there's a lot of moving pieces here. In your experience, which of these is the most important and why?
The quantity. It really is the quantity. Okay. Because once you have a product and once you have a product and you need it, right? But in the decision-making process that goes on day after day, it's the quantity. And I can sure give you a fun example that happens almost every time I'm on site doing this type of work. When you have the day after a sales call goes bad or the day after a customer gets shorted, you get together and there's a person that dominates that meeting, and they say this with all very good intent because they're serving the customer, which you need, and they'll say, quote, "Don't ever let that run out again." Now, when you hear that and you're in the operations and you're the one that is pulling the parts and ordering everything else, next time you go to order parts or next time you think you maybe should or shouldn't, you know where you're going with your indecision. You're going to order it. And at the end of the year, nobody has a party when you don't write off obsolescence either, do you? Which means you're just, and now it's for good reason. I know it is, but of course, I would like to think in the math of me, the mathematician says, no, let's get it right. So, but yeah, that across.
Yeah, absolutely. How about you, Bob? Bob, what do you think is the most important and why?
I would, from me, it's assembly. Steve absolutely nailed it on the quantity side, but me, a process is a process. You talked about the different industries I was in, all the way from automotive and aerospace to making pet food, and everything's a process. So whether you're using screws, nuts, armatures, or brushless motors, or using wheat, pork, and flavorings, it's still a process. So you always have to follow your steps whenever you're making whatever product it is.
So what's great about this is, for me, it's timing. So we did a project for Harley-Davidson where we combined 3 of their manufacturing plants into one, and we worked with Syncreon to make sure that we had the product coming in inline vehicle sequencing. So basically what we're saying is that, it's not an exact science, it's more of an art. So each manufacturer will have a completely different prioritization of what's most important in their supply chain. Very cool. All right, Steve, you were going to go to the next slide, and I just wanted to get some perspective on that.
Yeah, very good. Thank you. Hey, next slide, I'm just going to, following my outline, I'm going to give you a simple example. And it's a shovel. And it came to mind this week because of the snow in Milwaukee. We're getting some snow. So a shovel has, in this case, it shows 5 parts. There's some fasteners as well that aren't highlighted, but it's 5 parts. And that's nice. So I want to start on one extreme because we're going to build up and go to another, and I'm also going to try and keep the comfort that it is manageable. So let's go back to the supply chain. For a shovel, it's one design, 5 suppliers. I'm saying they have a few doors. They can process it as received. They have a Kanban visual replenishment with the fasteners, and then they have this discrete part 1-to-1 with the 5 components that were highlighted: the cutting edge, the blade, the socket, the shaft, and the handle grip. And then they can place it back in racks to be ready to serve the customer. So let's take the one example here. Let's look at that. Well, what do I do with that? That's really neat. Let's just look at that blade. Let's say that the blade comes 8 to a case, and a pallet holds 20 cases. And a pallet is 4x4, 6 feet high, and coincidentally, we use 896 blades in a day. for our sales and operations planning. So a truck can hold which holds 28 pallets, can bring us 5 days. 5 days. So simple enough. I got a shovel I got to build, and I got to know how much do I order and how often do I do it? Well, I have to order every 5 days. I need to order 2 days before I run out, and I order a truckload of 28 pallets. Now,
and Steve, you know, right there, right? What you need is if you're going to have 28 pallets of the same item, you don't put that in single deep selective rack. And if you can't do bulk floor storage 3 or 4 high, you're going to be either looking at some sort of drive-in rack or pushback rack, right? So, you know, obviously, when you start looking at your facility design and layout, you definitely want to take into account a storage type assessment to identify the ideal size and quantity of all the storage media that you need. But this is not that example, but while we're talking about it, that's near and dear to my heart.
Well, and that's very well put. That's exactly what you have to present now. This is what we have. Now I have to present what is it available to be stored in so that we can derive the best solution. But I just wanted to give this simple, basic thing that for this product, I can tell you exactly how much space I need and how much you're going to store. I can even tell you how often you have to reorder. And then we can start making judgments. Ooh, maybe I should order less because holding cost is too much. And maybe I can have it in LTL quantities rather than truckload. And these things can expand. But very basically, I just wanted to show one simple element of a plan for every part. And all I'm going to do is repeat that thousands of times. So let's add some complexity. Let's say I have 100 designs that I can potentially sell. And I have over 1,000 suppliers that serve 450 of those components on average per design. Well, already I've got 45 million combinations of design supplier component combinations. But all I have to do is that one thing I just did and repeat it continuously and manage and control for it. But it can be done. And that's what goes on. Now, of course, we're starting to open up the plant. We start to look at how many doors, how's it flow, what's the demand, what's the seasonal demand. And now we're just exploding it, but it's manageable. It's all as simple as a shovel and where you're going to put the pallet. So you ask, how could it be simple? Well, it's relational data. And of course, it's something dear to my heart, the decision science, which is, we like to say it's in algorithms, which is really data flow and decisions. So data flow and decisions, let's take this example of the plan for every part, and let's build on that and see what it is about the data. So first, I'm going to build up some key data elements. And here I show finished goods, components, bill of materials, suppliers, and plant dimensions. Then I'm going to talk about grouping, which is something that really starts in all the projects we do. Pretty much this is the order. That's what is your finished good? What are your components? What's your bill of materials, your suppliers, your dimensions? And then you get down with the group and you start talking about what groups can we create within the plant. So first, suppliers. Just get a database. Of course, there's, you got to get your IT folks. It can be location, it can be quantity, it can be response time, it can be history, it can be minimum order quantities, countries of origin, so forth. And there's a whole host of information that you'll have on your suppliers, particularly even which supplies they have, what supplies their history has been. Components. Now we get into a whole host of things that has a lot to do with your product, which can vary. Which product are current? Which ones would you want maintained by a vendor managed? What's the value of the components? How do they store? Is there any temperature requirements? What type of sub-assembly processes do they have to go through? So I'm just building this base, which is generally data that we all have in our systems, just building it to get ready to expand on it. Bill of materials. There's got to be a control for what goes into what at several different levels. That can go down several levels into the detail, into sub-assemblies and sub-assemblies of sub-assemblies and so forth. But it's whatever data you have, and you build that and get ready to build that relationship. Finished goods, well, that's what we sell. We want to know what it is, what are the pricing, where is it going, what's the material, what's the cost, what type of tooling, units produced, what's it take, what's the storage requirements, and so forth. Sales and operations planning. Well, not everything is uniform. So if we're going to have a plan for every part, we should know what is the time interval that we expect? Because if I'm not building something until a particular month that goes out a month later, I certainly don't need that part at that time. So the plan for every part can be time-based as well. Then the plant groupings, and this is where the fun begins. Anytime you're in a group, or you're in a plant, you're in the operations, and the data geek brings it all, and you bring it together, and then you've got all the things that you hear about. Hey, what about this? Hey, what about this? We can't do this. We can't move that. Hey, we have to have that product over here. You know that. And you go through, and what I do, and this is really the start of the process, is you put it all on the board. You put it on the board and you say, okay, what's important? What's its dimensions? What's its use? And then you really start to open up what's needed and why. And when you get through that exercise, what you have is an identification of all the needs within your plant. You haven't even applied any math to it yet. You just have decided it is needed. I remember one facility I did one time, it was the fire station. There was a fire station right in the middle of the plant that had a whole host of wiring and control going to it. And out of it came, you just could not move it. That had to stay. And I don't even remember why, but it's one of those where in all the demands and all the groupings, that fire station had to stay. And it was about 10 foot square, probably 20 feet high. So anyhow, now we're understanding.
Believe it or not, it is a big part of it, right? When you start to look at laying out a facility or a design based on the inspector, every county has a different code, clear heights, sprinkler systems, electrical, those types of things. Sometimes you can't do what you want to do, and you got to work under a constraint, right?
No, absolutely. And and one of the things in working with the teams, it's a chance for everybody to identify and become part of the process, so that when they put something on the board that really is important, it is, and you quantify it, and it really does build that grouping to understand those things. And of course, as a practitioner, you got to hear it, because you sure don't want to be the one that suggested taking the fire station away, do you? Yeah, so anyhow, the elements.
Just real quickly, I really want to remind everybody that we have a Q&A and a chat bar at the bottom. So if you have any questions, we'd be happy to answer those throughout the process here. Go ahead, Steve. I'm sorry.
Yeah, very good. Very good. Thank you. So there we are. In my process here, I talked about understanding the elements. After building the base, I should say, as expanding the base, we have to understand the elements and build that relationship before we can start to ask questions. But isn't that the beauty? We understand the elements that we just put in our base, we build the relationships, and then we start to ask the questions. And I'm going to give a very simple sample for that right now. The question was, hey, where, what, and how much can I store? This was combining some plants as well. And the two plants were coming together and go, okay, my gosh, well, we had all this product over here, and we stored it here, and we stored it there. Hey, I don't know if we have enough room. So what, where, what, and how much can I store is the question that was presented. Additional information needed now: component dimensions, storage specials, the cumulative time-based demand for all those finished goods, all the lead times, minimum order quantities, store types and related densities of the product that's stored. Where's it going to be used in the plant? And for that matter, cost of holding, which drives a lot of the, how much we decide to order. Well, here's all my base data. And I said, you have to understand the elements and the relationship. Now, this is just arrows pointing to the different buckets that we put it in, but it matters. When I'm buying something and it's packaged, that has an impact on how I'm going to store it. When I'm purchasing something that's going to go to assembly, how I buy it and how it arrives has a lot to do with how it's going to flow through the plant. The logistics, how it's going to move, and what the cost is. All these things, there's a relationship among them. Now, there isn't that you have to have and understand every infinite relationship, but you need to focus now on what the question being asked. And in this example, it was, where, how much can I store? So what's it look like? Put all this into a user interface so that I can pull this data and start asking these questions. This is a sample of some of the user interface I have used. Here I have the finished goods, I have the components, and I have a facility, which is really what is going on inside the plant in this particular example. And then we have to make the decision support, which is where we get to the heart of the evaluations. The finished good has specifications. It has the sales and operations planning. It has the distribution of where it's going. Components, you got a component master, you got sub-assemblies, the bill of materials, the placements, you got these groups, you got component overrides when that's necessary, standard packaging, country of origin, which leads to lead time, buffers that you're planning for, and so forth. The facility, well, we're going to put it in the facility, so I need to know my pallet density, sections throughout my facility. What's my rack profile? I can present alternatives. I have what we have what's presented, and we can start presenting alternatives that may, through the use of the algorithms, determine it more suitable. How much is required, stow addressing, and there we are, those facility groups, which you got to have. Then in the decision, then you get to it, calculating current requirements, and assign storage groups to stows and so forth. And that's what this particular sample is going to focus on. So storage, we need to know pallet density. We need to know rack profiles, stow dimensions, which has a specific address. Now, I said we had to identify all the groups in this plan. And in that, we also have to identify every location, every square foot is part of something. It can be an aisle, it can be a rack storage, it can be assembly plant, it can be the restroom. Every spot in that plant has to have something identified. And in that as well, you can see I have on the right there, I have a rack profile that's presented. Now, if we so see it and we feel it's necessary, we can change the profile. That could be instead of the 4 high that it is or 5 high that it is, we could change it and have some smaller levels and so forth. So all that gets presented into the algorithm, into the model, and then we go through these specials. Earlier I said we had to build the base. We took the bill of materials, we took the suppliers, the components, the finished goods, and the groupings. But now we're taking all that and we have to expand right into the decisions. That is, how much do I need on hand? How often does it move? How much does each one take up? Which line would these components be for? And continue that evaluation. Still, as simple as a shovel and where you put the blades. But I'm doing it time and time again. I'm doing it thousands of times, and I'm comparing it with other decisions that have already been made for competing space, of course. So here's take a look. Let's take a look inside.
Yeah. Before we get into that, okay, you go through all this math and science, lessons learned. Do you have any examples of where you were done and then, somehow, some way, situation, somebody said, hey, this isn't actual or accurate? What's some lessons learned here?
Yeah, you mean the naysayers, perhaps. You're always dealing with the challenges. And I said earlier, you have to ask about, what goes into it. What matters, what has to stay. And people can always say, we need space for that. We need space for this, and it can go on. Well, in the end, a particular plant I did one time, in the end, I would say this is it. You asked for this much on hand, you asked for this much buffer, and I said to the folks, this will happen. And of course, some people in the operations are a little tentative about it. But this particular gentleman, I remember him, he was saying, I just can't imagine it's ever going to happen. I just don't believe it. And within about 3 months, sure enough, he called me up and he was almost proud to tell me, Steve, it doesn't fit. We ran out of space. I said, no, come on. He said, yeah, absolutely it is. Okay, well, just do this for me. Would you go back to the procurement group and just ask them if maybe they've, and this person knew the component that didn't have room for it. I said, would you ask them if maybe they bought more of that than what was in the design plan? And yeah, they had a meeting, and the next day, this gentleman called me up, a little bit of tongue in cheek, and he said, yeah, you're right. They had a deal. They got a deal on some product, and they overbought, which can be for good reason. But the nice thing about it was that it built the faith in the result that the math was working. And for this person who was kind of a bit skeptic, it kind of gave him a little strength going forward. In fact, he was able to say to the procurement group, hey, if I don't have space, I know why. You bought too much. So it was that was a testament to the math.
Well, that's real world, right? I mean, a lot of times the buyers get a phone call at the end of the month or at the end of the quarter, and there's an opportunistic buy. And if you've got the right planning tools and the right, numbers, you can say, hey, I normally buy 500, but because of the special price, I don't want to buy 5,000, but hey, I'll buy, 1,250, and knowing that that's the right price, right? And that's great, but it doesn't impact, or they are not thinking downstream how it's going to impact the space within the facility. So,
yeah, and it might very well make it the right decision. I wouldn't have said in that case that was a wrong decision, but just know that you have to accommodate for it some other manner. And of course, even that matter, often people will say, well, hey, give me a buffer, give me a little buffer area, because you never know. And of course, that could be the type that maybe should have been done in that case. Maybe a buffer should have been planned for extra space. And perhaps it was and taken up by something else, but
Yeah,
it doesn't mean it's a bad decision. So, but that's what the math tells you, and it's very powerful. So,
absolutely.
so here's to take a look in the inside of this particular one. This is the plant that a plant that I did. This was combining 2 plants, and if you look just about dead center off to the right, you can see some blue and you can see some purple. Those are the assembly lines presented. Those are fixed, and there's some sub-assembly next to it. And it was, okay, Steve, let's see you do it. Well, what I say, the first thing you got to do, you got to name everything. And here's a expansion of one of the areas that we named. You can see right in the center the letter SG26. I don't remember what that really references anymore, but there it is. That had a meaning. That SG is referencing those racks. That's stand-up rack. Over on the left, you see SG44. There's the battery chargers. That's where the battery charger is going to go. SG33, more rack, and so forth. So all of this has to be identified. The entire plant. You're also looking at the end solution, which helps. But all those things are identified, and then all their needs, which are associated with the flow of parts from supplier inbound to assembly and out. I've got them tracked, and I can tell you where it's going to fit and how it's going to move.
I'm going to ask Bob for his feedback in a second, but one of the things that I see most often, and it's the little things, it's called a location addressing system. So you've got all of these locations in your manufacturing plant or in your raw materials plant or in your finished goods plant or your wet plant. And it's like a home address, right? The mailman knows what street, what building, what apartment, whatever, and knows exactly how to get there. And so one of the things that we always see is that the location addressing system isn't consistent, and it doesn't go to a specific position within an aisle, bay, level, row. And that's one of the lessons learned I see. How about you, Bob? When you talk about layouts and those types of things, what's a lessons learned that you see or a common thing?
I would say that having to minimize your flow, one of the things we like to use in examples like this is a spaghetti diagram, and it shows where every component goes from the time that it enters the plant until it is a finished good and it's going to the shipping dock. And if you can eliminate some of the pathways that that material flows, or reduce the pathways, your process is going to be much more efficient.
Agreed. I love it. You said spaghetti diagram. That's normally what people say about a system, but I think, when you're done, but you do a travel path and see how many times every item moves and this and that, that's when it becomes a spaghetti diagram. So
yes, exactly. Yep.
All right, Steve. Sorry, back to you, bud.
Well, geez, I want to emphasize your point about having an address system where everything is identified, and that's what you need to do. While it seems overwhelming, wow, every address, well, it's a computer. It doesn't matter. Just have every address, because every part needs a place, and then there's following the rules and so forth. But naming everything is just critical. So then in this one, here we are. Here's the solution. I shared with you the need for the naming. It went through the algorithms, all that we showed some screen prints of the user interface. And here it is. If I start up in the upper left-hand corner and go clockwise, there's our rack. There's some rack storage. Then we have some sub-assemblies. We have the assembly lines. Over on the upper right, we have the just-in-time inbound. This involved, of all the components, one component made up about 80% of the whole thing. And so that would come in the upper right and feed to the lines. There were 4 assembly lines. Then there was a boxing area after it was good. Finished goods were stored down here in the bottom of the screen here. The VMI, vendor managed inventory, was down in the lower left-hand corner there. And that will come up again. That was quite a fun group, and we learned a lot with them. There's quality inspection. And then there's a whole host of places where there was components. But you can see, if you look at it, the components, in a sense, on the inbound are right across the aisle from the finished goods in the end result of this particular layout. And we have the inbound staging. Then we had a specific area for Kanban supplies, which came material in another finding as well that I'll point out. So in the end, there it is. There's a spot for everything. Everything has its name. Everything is part of a group. Everything has a use. Everything has an origin. Everything has a flow. Now, never works to plan, of course, because customers don't buy what we tell them. But anyhow, it was set up, and that can flow through in that manner. So that's the shovel extended thousands of times. And we have great fun doing it. So here's, what am I back to? Oh, I'm back to, this is beyond the question. The question presented was what, where, and how much can I store? And if you look, I highlight that in the middle that was achieved. But in this particular project, you know, a math guy can have a lot of fun when people really want to hear about it. These are some other things that came from it. The product design, for instance, and that came from the VMI people. They had asked, you know, you've got all this data. Tell me, I'm holding a screw with the same thread and the same head that's 5/16 and another one that's a quarter. And I says, I know it doesn't matter because I've actually messed up and the customer has never even noticed it. I've given that quarter where they've asked for the 5/16. Now, and what happens is, and we identified that, brought that, and of course, the vendor then was able to achieve a better pricing because they weren't asking for two different designs and so forth. And they were actually able to hold less inventory because now they don't need to duplicate all that. And small, I don't remember the dollar amount, but it was a small fun thing that came out of that when they started to realize, wait a minute, you really have all that. And you start doing these comparisons. Component sourcing, another huge one. Particularly even supplier negotiation. I mean, you can bring this data back to your suppliers and say, hey, here's what we see. The minimum order quantity is really driving up our cost of holding and our space availability. We'd like to be able to get a lower quantity, minimum quantity, and we don't want to pay for it. And you know, you can negotiate that. Another thing within component sourcing, a huge one, was an alternative domestic supplier. If we're planning for 85, 80% or 90% of plan, and we don't know what's going to happen, we can minimize our risk of obsolescence by bringing in less overseas and then respond when it does hit with a domestic supplier. And that was certainly something that came out of this project as well. Very much related to the next point, the minimum order quantities. Packaging was huge. We had a lot of suppliers that were nearby, and we just used returnable packaging that could go right to the line. And that certainly helps all the receiving and so forth. Packaging, consistent with that of the supplier needs, the inbound door specific assigning. So suppliers are given, supplier and carrier will be given a door. You're carrying this component for this line, come to this door. And that was very successful as well. The component flow, the component storage, and the flow. The Kanban was quite interesting because it was in a specific area, it was identified, and then we could say where everyone thing was, and they knew how much they were going to use. So we had fast movers in the Kanban. For that matter, the question came up, how do we move it? And do we move it with other components as well, both the visual Kanban and these discrete items ordered? And we went into a design of some equipment, a tug, a carton tug, much like a golfer, and that was what was being used to flow to assembly. And then this finished goods came as well. The design that you saw would not hold the finished goods in peak season. Well, obviously, it doesn't need to be there. It's ready to sell. Where is it going to be sold? Let's move it. So we positioned inventory on a seasonal basis closer to the demand and was able to serve the demand much better because we said, well, let's move it out until it needs to be replenished from the general storage. So just a lot of stuff that can go beyond, beyond the question.
Steve, what's interesting is, we talked about plan for every part. We did the finished goods, we did the planning, we did the components, we did the breakdown, we did the flow through the facility. But then you think about the rationalization, like, if they're using 6 or 7 different types of ball bearings when they can standardize on one, right? If they can start to think about minimizing the number of suppliers, well, wait a second, right? Domestic versus international. I mean, if the global pandemic put a spotlight on anything, we've got clients right now that still aren't able to get product in from Asia, but they can get it from Thailand, Vietnam, or South America. So it's interesting to see how you really need to today think about diverse and alternative suppliers and how it's going to impact your supply chain. But the one here that gets me, right, is the finished goods storage regional for peak. So while I did a really nice project with Harley Davidson, I also did a really cool project with Miller Brewing Company, What we had said is that if we could take the kegs off the end of the line and put them directly into the truck, we could eliminate damage and extra material handling. So we did an analysis and we said, okay, at the end of the manufacturing line, is there a demand for this Miller Lite or Coors Light right now? Yes or no? If the answer was yes, then we went to the second question. Do we have any product in our facility older than 10 days old? If the answer was no, we took that keg directly to the outbound shipping. If the answer was yes, we put it away and we put it in reserve, and then we'd move it to the pick location and then pick location down. We were able to take 34% of Miller's kegs at the end of the line and put them directly into the outbound trailer, which has a huge impact on their actual storage needs. So it's those things beyond the question that can allow you to change your process. Bob, I don't know if you've got an example that you can share that, is in these, kind of other ancillary areas that, would be a good aha for us.
We had similar things. Pet food is very time-oriented, shelf life related. And so I had created an internal Excel sheets to utilize what we had in-house and put green, yellow, red around using minimum order quantities, max storage quantities, and be able to know on a weekly basis what we needed to make the next week. If it was red, we made it immediately. If it was yellow, we made a decision as to whether to make it. Going to the kind of the Kanban type of system, we just based it on what was in the plant, and to as you said, basically bring it off the line, put it on a truck if that was what was required.
Absolutely. And you know what? The world runs on Excel, so it's okay. All right, so let's go to the next slide. And then again, we've got
here we are.
Q&A and chat on the bottom. So let's say what we said, right? So we said we were going to talk about what a plan is for every part. We used a simple example with the shovel. We added some complexity. So once you understand all the things that's required for one item, think about if you have thousands of items. Then we talked about the data and the decision modeling. Obviously, storage type analysis to identify the ideal size and quantity for storing all the raw materials and the finished goods, as well as the process flow and a location addressing system. Then we talked about some sample applications, and my goodness gracious, if that wasn't enough with all those moving parts, think about the other findings. So we want to open it up to any questions. Please use the Q&A and chat. And then Steve, if you'd be so kind to go to the next slide. I think the big thing that we have is, where do you go next, right? So as Alpine, we've got a manufacturing best practice assessment that we can help you answer your question. Build the base. Where do you start to explore? And how do you identify the money and the impact? So we are absolutely here, excited to launch our 5th pillar, and we really appreciate the time and attention. I don't see any questions or anything on the chat bar. So at this point, I think we will end the session. Thank you all for your attendance. We really appreciate it. My panelists, Bob and Steve, thank you guys so much, and congratulations on launching the manufacturing pillar. Have a wonderful day.
Yeah,
stay warm.
Thank
stay
you,
healthy,
everybody.
everybody.
Alrighty.
Absolutely. Thank you.